Okay, so I want to give you some notes on graphing inequalities, and again, based on like last year or what you remember, or things like what you covered in Hot 2. Some of this might look very familiar and seem review, and some of it might be a little bit new and challenging, and that's okay. So the whole idea of an inequality is now where it's not equal to, but you're comparing it to another number, and we usually compare it to 0, looking for, is it positive or is it negative? And this one is strictly greater than 0. Now, one way to do this is to draw a sign chart. And there are different ways to draw sign charts. And the way I like to draw a sign chart is the first thing I like to do is identify the zeros, pretending it's like equal to 0. And the values that make this equal to 0 are -2 and 3. Now, those values are the zeros there, and what ends up happening, since those are the zeros, is that they divide the number line here into 3 regions, right? Things that are bigger than 3, things that are in between -2 and 3, and then the things that are less than -2. Okay, so those are the 3 regions that this number line is either going to be positive or is going to be negative, depending on what you pick as a representative, like what the behavior of the function is. So I'm going to pick a representative from this section here, and I can pick any representative, and the behavior of that region will be the same. So let's say I pick like x equals 4. 4 is like right there. If I put 4 into this function and evaluate what's happening, and I don't really care as much as what the value is, as much as I care about, like, is it positive or is it negative? So if I put that in there, and here's what I'm thinking. You don't have to write this necessarily all the time, but I'm thinking 4 minus 3 squared times 4 plus 2. So 4 minus 3 squared is 1, 4 plus 2 is 6, so 6 is positive. So I know that this region over here, every number I pick will represent a positive output. Okay, so then I'm going to pick a representative in this region here, and maybe a nice representative pick is x equals 0, because 0 falls like right there. And if I put 0 into the first equation, like right here, that gives me -3 squared, which is 9. 0 plus 2 is 2. I get 18. And again, I don't really care that I knew how to get the math of 18 as much as I care about the fact that this region is positive. And then negative something over here that's less than -2, let's say like -3, I can analyze that, and if I put -3 into the function, that's -3 minus 3 is -6 squared is 36. -3 plus 2 is -1. So my overall product is less than 0. So it's negative. Okay. So I have 3 regions, and because I identified the zeros, that divides it either into positives or negatives. And I look at the problem. I want things that are greater than 0. So now that my sign chart visually shows me where the positives and where the negatives are, I know that the solutions would be anything from -2 is less than x is less than 3, or x is greater than 3. And notice I have to make sure I'm strictly less thans here, strictly greater thans, because my inequality is strictly greater than. And then today in class, we looked at interval notation. So in interval notation, this would be -2, 3, union 3 up to infinity. And remember, interval notation, when it's strictly open like this, it kind of looks like it's ordered pair, but it's not, simply because we're in the context of this being an inequality. Okay, now another way to think about this problem too is what if I had asked you to graph this, like f of x is equal to x minus 3 squared times x plus 2. The process would be very, very similar, right? I mean, if you think about, you'd say, okay, my overall power function, my p of x would be x cubed. That's positive. So a positive x cubed starts here and ends here. My zeros would be 3 and -2. And because 3 is even multiplicity, it's a bounce. And because -2 is an odd multiplicity, is a cross through. So my graph would look something like this, right? Okay. Now, if I want things that are positive now, all of a sudden, think about where do those values exist on this graph? It's everything that's above the x-axis as positive, and everything below the x-axis would have been negative. So look at your x components. When is, right, like when are your x's giving you values that have a positive y? So from -2 to 3, and then 3 to infinity. And you could almost superimpose that graph, right here on my sine chart. It goes up like that, okay? And then my last piece that I want to show is that using multiplicity, I think, is super, super useful because if you know that the multiplicity of one of your zeros is even, that means that that zero, so at 3, right? That zero on both sides of that zero has to behave the same because it's a bounce. So if you knew like one side of that was positive by picking a test point, then your other side would also be positive because that's the match. And then if your multiplicity of your root or your zero is odd, like that, we understand it's a power of 1, so it's an odd. That means that on either side of that particular zero, you know that the behavior has to switch signs. So if one side's positive, one side has to be negative. So I'm going to refer to sort of all three methods. Whether you pick a representative in each particular region and do it just checking, or you could pick a representative in one region and then just fill in the rest by knowing multiplicity. Does it change signs or does it stay the same? Or you could think about it as an equation and graph that. Okay, so I gave you a lot on that first example, and it might be worth your while to revisit that one, this one video before looking at the next one, and I'll go through a couple more examples.